Hello guys, and welcome to part 2 of the Skyrim tutorial series. In this video we will find the entity list in Skyrim. I will show you how to hook there and how to create an array which contains all entities which we can use to loop through. We will also use x86dbg, the debugger, and ReClass to create our ReClass table and the classes we will use. It would make sense if you had a look at Rake's ReClass tutorial before, so you know what's going on, and I will show you how to create the working signatures with a debugger, and your hack will be able to survive future game updates. Just a quick reminder, it can happen that the game will crash when you try to attach the cheat engine debugger. This has nothing to do with Steam trying to prevent you debugging the game. This is more of a Windows security system. There is a very nice website, it's called The Hacker Within. He is describing this problem very good, and he's providing a fixed DLL which you can inject directly into Steam, and from then on you will be able to debug any Steam game without problems or crashes. And of course, you can do this at your own risk. Don't do this and try to start VAC protected games. You will get banned probably. And if you decide you want to try this, you can download it here. It looks like this. And you just pick Steam from the list. And you have to do this before you start the game. So you inject the DLL, and from then on you start Skyrim and you're good to go. Okay guys, let's get started. I can give you the tip to use the V debugger because the Windows debugger will crash the game a lot. And also to use hotkeys for specific search options. Okay, what we're gonna do is we want to find the entity list, a list which contains every entity in the world, in the game world, and also our player. So what I'm going to do is I'm finding my own coordinates, and from there I'm trying to find the list which contains not only my own coordinates but also every other one's coordinates. So what we're going to do is, as always, we attach the juicy cheat engine. We change the search to float, we set for an unknown initial value, and we increase and decrease our position. That's why I'm standing here at the stairs. By the way, this is a position, it's 5 minutes into the game from the beginning. It's easy to find for you, and good to find all the stuff we need. Okay, so we decrease the value. Now I'm going up again. Increase, 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 decrease, 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 and increase, increase, increase. That's it. At this point, I assume that my character have to be in some kind of list or array, and I thought to myself that this can't be really static, so I started with the non-static addresses, the black ones, and made right clicks and had a look what accesses this address, and thought to myself that when my character would be in such a big list with all the other entities, then more than one address would access this list. So it can't be really an address with just one result popping up. So I had a look in every one of these and basically checked what other addresses were accessing this one. And as you can see, here's a lot of stuff going on. And I can tell you from my experience that I checked every single one of them. And there's one very interesting address on here, which is 6C6BDC. So if we have a look in the disassembler, you see this. And keep in mind that we are looking at our Z coordinates, at our height coordinates right now. So if we can assume this is our height coordinate, then we can assume that this is probably the Y and this is the X coordinate. If we do a right click on here and check find out what addresses this instruction accesses, set this to float, you will see this. This is a list of every address which accesses this assembly line. And as you can see right here, these are all Z coordinates. This is a different entity, this is an entity, this is an entity, and this is all Z coordinates. So what we're going to do now is, let's pick this one for example. And as you can see, 3C is the Z offset. 3C is the offset for the Z coordinate, and we can assume that ESI is the base. So what we're going to do is we pick this one and we subtract, in this case, the 3C to get the base. Copy this one, then we're opening ReClass. Then we attach our game, make a new class, paste our address, and expand this one a little bit. Then we can see 3C is the Z, this is the X, this is the Y. So we can set this one to vector 3 right now, because we know these are the coordinates. And I can tell you from my experience that in here is this is a pointer, and if we have a look in here, let's expand this one a little bit. On offset 88, you will see the entity name. In this case, we are looking at the coordinates from a skeleton. So we can set this one to a picture and name this name, for example. Then this is the name pointer, and this is the name pointer class. So we have the name. This is in this case player end. And let's try this with a different entity, just for the sake of it. Where is it? Here. Okay. Let's go. Same procedure. We subtract the 3C. We go back to ReClass. We add the address. We go inside our name and we see Frostbiss-Spinne. Now you learned something new in German. This is some kind of frost spider, you could possibly imagine. And this is our ReClass table so far. Of course, it's not very much in there, but it's enough, and it will work for us. So what we are going to do is we go back to home, click generate. In here we have our player entity and the name pointer class. So we pick this one, say copy, go back to our project and paste the shit in here. I already made a header for this one, hooks reclass.h. We paste this in here. And now we have to rename the vector3, because I think I named it vec3 inside the function header. Yes, it's vec3. All right. And now we can unselect this block. Perfect. Okay, so we basically found a list of Z coordinates, and you probably ask yourself now, how can we make any use of this? Well, the answer is quite simple. What we're going to do is we will create a hook at this address. We will log every address which is accessing this line, this assembly line, and will write the address to an array. So in this way we can log every entity which is accessing in there, and we also know where their beginning of the entity class is, and we can use this to create an ESP. So what we do now is we create a signature for this line of code. So we will find, or our program will find this line of code again even when the game updates. For that we need our trusted debugger, and you will also need a plugin called Swiss Army Knife, which will give you the ability to create signatures. You can also use OllyDbg for this one, but I would suggest you use the newer x64 or x86 debugger. I will also give you the files you need to include to make this plugin running inside my tutorial thread, so you can use this one. First, we will attach the game to the debugger. Now we have to press F9 to make it run again. Then we need to double click in here and get the address 6C 6B D6. Press Ctrl G and type this in, 6C 6B 6. No, D6. Now you can close this one, and we create a signature. Let's just make a signature of these 4 lines. Go to plugins with Army Knife, signature, and create signature. This is, you can also create signatures either style or this is, I think this is something else. No, it's the same. I never used this one. This works perfectly for us, so make a copy of this one. And inside our code in the DirectX CPP, I think very at the bottom, I made a thread. It's called initiate hooks, and in there you can overwrite the dummy address with this one, and we also need the mask. So one point before doing so, normally you should scan first, and down here it will tell you how many references it found in the memory, and you should always go for one reference, because if you found more than one and you're using the signature, it can happen that the hook is placed at the wrong location and your hack won't work. So, but now we found just one, and we can assume that this one will work. So we cut the connection to the debugger. We can close this one. So now we can activate this one here. And I made a little message box address code, which I like to run to test if a signature is working. So what it basically does is it produces a message box with the address found by the signature you put in over here, and it will also copy this address to the clipboard. It's a little bit easier to search for this one. So let's test this real quick. Right now no hooking is taking place. So if I compile this and I inject this in here, you see there's a small message box coming up, and if I press OK, it's already my clipboard. And if I go to address, paste this here, it goes directly here, and I know, okay, my line was perfectly found. Alright guys, time to test our hook. Let's go to the code and let's disable the message box and enable the hooking procedure. I hope you are familiar with hooking. If not, I give you a short introduction. You can count the bytes in here. It's 1, 2, 3 for this line and 3 more for this line, and we need a minimum of 5 bytes to create a JMP in assembly. So basically we jump to a different location, execute our code, and jump back to where we left the code. So what I'm doing right now is I'm counting these bytes here, 6 in total, and the address from the assembly line our signature was found will be assigned to entity Eddie, and the address where we continue the code later on when the hook is done basically is this address plus 6 in this case. So these 2 lines will be overwritten with a jump instruction. Inside the code cave we will execute these 2 lines of code, and then we jump back to this location plus 6. So we will execute the code in here, and it will just continue the normal code flow. So back to the hook itself. ESI, which is the entity base, gets moved into entity object start, and as soon as it's not empty, we will enter a loop and check if the entity is already in our array. And if so, we will leave directly without adding the entity to the array. And if it's not, we will enter another loop and find a free spot and adding the entity to the array. Now please compile the DLL quick, and let's try to inject and see how it looks like in game. Awesome. So let's start the game again and inject our juicy code. Okay, so let's start the game again. Let's continue where we left. And right now, if everything is working as intended, nothing will happen. So if the hook would suck at some point, the game would crash. There's no question. So if we inject this and we go back in game and it's not crashing, you can assume that your hook is working. But to make sure, we will quickly debug our own hook and also the array. To do so, you have to close the game again. Start it again, please. So now we go back to Visual Studio, go to debug, mine is in German, I'm sorry. Debug attached to the process. Then you can search for, I think it's the Elder Scrolls, so TES, yes, T Skyrim. You have to start the game before, otherwise you won't find this process. Now it's attaching Visual Studio to the game. By the way, this is a procedure you should really master. It's very important that you're able to debug your own code, and Rake made an awesome video about that. Have a look at the forums. The first half of his video is for external hacks, and I think at around the middle of the video he starts to explain very well how to debug internal hacks. It's awesome, you will learn a lot. Okay, but let's continue. So what we're going to do now is we're going back in game again, and then we will inject our DLL. Oops. So let's inject the DLL. Okay, so the reason nothing happens is because we didn't set any breakpoints yet. But we jump around And right now, probably a lot of entities should be inside our array already. So what we're going to do now is we go back to the hooks ReClass header and set a breakpoint, for example, directly at the beginning of the hook. And if you go back in game, zack, the hook, the breakpoint triggered already. And you can, for example, add here now our array, the ends. And if you open this one, wait a second, you can wonderfully see we have 24 entries of entities in our array. If we open this one here, for example, we have their name pointer. Inside we see it's a skeleton, or you can open the coordinates, and here you have the skeletons X, Y, Z. Or for example, you can open a different one. You see this is a beer, or this one. This is what is it called in English? A torturer. Yeah, a torturer. And this is something you should really use in your own hooks, and to check if your arrays you create are working. Just inspect them and see if they are working as supposed. And we can see everything is in here. We have our coordinates for every entity. We have the name, which we can use. And now we are basically ready to write the actual ESP and just loop through this array and draw all the information on screen. So yeah, hope to see you in the next video. Have a good day.